Welcome to week 3 of technical drawing. Having mastered the true length of lines, we now extend that knowledge to find the true shape of plane figures. A plane figure is any flat shape, a triangle, a quadrilateral, a pentagon, that lies on a flat surface in space. When this surface is inclined to the principal planes of projection, the projected views of the figure appear distorted. The triangle may look compressed, the square may look like a narrow parallelogram. Just as we needed the true length of lines for accurate measurements, engineers, architects, and fabricators need the true shape of plane surfaces to cut materials correctly, to lay out sheet metal, to build roof structures, and to solve many practical problems. In Nigeria, roof trusses, solar panel installations, and billboard construction all involve inclined planes, and workers must know the true shape to cut and assemble components accurately. The method for finding the true shape builds directly on the auxiliary plane method we use for true length. We will draw a new auxiliary projection plane that is parallel to the inclined surface. When we project the figure onto this parallel plane, we see its true, undistorted shape. Before we learn the construction, let us understand the condition for seeing true shape. A plane figure shows its true shape when the projection plane is parallel to the plane of the figure. Think of holding a piece of cardboard flat above your desk and looking straight down. You see the true shape of the cardboard. Now tilt the cardboard, you see a distorted, compressed view. The same principle applies in technical drawing. In the plan view, we see the true shape of a plane figure only if that figure lies flat and parallel to the HP. If it is inclined, we see a foreshortened view. To find the true shape of any inclined plane, we use the following approach. First, find the true length of one edge of the plane figure using the auxiliary method we learned last week. Draw an auxiliary reference x1, y1 parallel to the chosen edge in the plan view. Project all the vertices of the figure onto this auxiliary plane, measuring their heights from the elevation. Connect the projected points to get the first auxiliary view. Now, in this first auxiliary view, the inclined plane will appear as a straight line. This is called the edge view of the plane. Next, draw a second auxiliary reference x2, y2 perpendicular to this edge view. Project all the vertices perpendicularly onto the second auxiliary plane, taking their distances from the first auxiliary. The resulting figure is the true shape of the inclined plane. Let us trace through a typical WAEC style problem. We have a triangle ABC inclined in space. We are given its plan view, triangle ABC, and its elevation, A', B', C'. Step 1. Choose edge AB. Draw x1, y1 parallel to AB in the plan. Project A, B, and C perpendicularly to x1, y1. Take the height of each point from the elevation, the distance from the xy line to A', to B', to C', and plot these distances from x1, y1 in the auxiliary view. You now have points A1, B1, C1. Connect them. If done correctly, A1 and B1 will lie on the x1, y1 line, since AB lies in the HP for this auxiliary, and C1 will be above. Edge A1, B1 shows true length. This first auxiliary gives an edge view. Step 2. Draw x2, y2 perpendicular to A1, B1, the edge view of the plane. Project A1, B1, C1 perpendicularly onto x2, y2. Measure the distances of each point from x1, y1 in the plan and mark them in the second auxiliary. Connect A2, B2, C2. The triangle A2, B2, C2 is the true shape of triangle ABC. Measure its sides and angles. These are the actual dimensions. Practice this with different shapes until the two auxiliary method feels natural. Today we learned that the true shape of an inclined plane is found using double auxiliary projection. First auxiliary, draw x1, y1 parallel to one edge in plan, project all vertices using heights from elevation. Second auxiliary, draw x2, y2 perpendicular to the edge view in the first auxiliary, project vertices using distances from plan. The second auxiliary gives the true shape. This method applies to triangles, quadrilaterals, and any polygon. In WAEC examinations, questions on true shape are common and carry many marks. Approach them systematically, label every point, draw projectors lightly, and check that each auxiliary is set up at the correct angle. A common error is forgetting which distances to carry from which view. Always take heights from the elevation into the first auxiliary, and breadths from the plan into the second auxiliary. Practice at home, draw an inclined square and find its true shape before our next lesson on intersections of surfaces.